Hello, my name is David Gollob. I'm a platform architect with Microsoft, and today we're going to be looking at adding spatial intelligence to your data. I have launched a report from SharePoint, and this report will show 311 incidents around a roadway within San Francisco. So first we'll define a 100-meter buffer to draw around a roadway within San Francisco, and I'll choose Ocean Avenue. And then for Ocean Avenue, I will choose the 1¼ mile segment beginning at milepost 1.26. And then within that buffer, there are a number of 311 incidents that have been reported. And I will choose those related to graffiti on private property and graffiti on public property. And as you can see from the names of these incidents, if you don't know what a 311 incident is, it's typically it's a system that enables the citizens to report in something that needs to be cleaned up or rectified within the city. Maybe an abandoned vehicle, maybe a sewer storm flood, street and sidewalk cleaning, and of course things like graffiti. Anyway, the list of 311 incidents goes on and on. In our case, we're interested in graffiti. And I will now apply those report parameters, and we will render the report. And now you're looking at Bing Maps as rendered through a reporting services report. And I've drawn in yellow that 100-meter buffer around that road segment for Ocean Avenue. And then you can see these dots, and these are points that represent the location of some 311 incidents. These all happen to relate to graffiti, and if the incident is red, it means it's been open for a long time. It hasn't been closed, it hasn't been resolved. And green means recently opened. So you could see how this may serve some purpose with the ability to manage street cleanup, cleaning up abandoned vehicles, cleaning up graffiti, and then being able to continuing to extend this buffer maybe to 200 meters next time and clean up not only around a given roadway in our case, but around the adjacent areas as well. So let's talk about what we had to do to the data to condition it to be able to render this kind of a report, and that's really what part one is about. So first of all, I have a database, SanFran 311, and I've loaded an Excel spreadsheet that I received from the customer, and I just call it the SanFran 311 stage table. I've already loaded it, but let's take a look. There's around 1,800 311 incidents, and you can see there's a number of attributes for a given 311 incident. The duration it's been open in hours, what's the subject, is it city services, is it recreation and park, the reason, is it a service request, what's the type of service. But if we go to the end of this result set, we can see that every row has a lat long. And those are just simply, those are float data types. That's not taking advantage of a spatially aware data set. It won't allow us to do or perform that kind of query that gave us that report rendering. So let's take a look at how we would do that. So I'm going to set up another table. It's called my report table, and it has all the same columns as the stage table. There's one exception. I've added at the end an additional column named incident point. And if we look at that schema, let me just zoom in here. There it is, incident point. And incident point, as you can see, is a geography type, and that's a spatial data type within SQL Server. So we want to take the lat and the long, or should I say the long and the lat, because that's the way we're going to organize those. I want to take those floats and I want to convert them to a spatial data type. And I'm going to use something called a well-known text format to do that. So there's a method for the geography type. It's a static method. That means we can call this anywhere without having to have declared the spatial data type. It's static. That's what this geography : : It means you have access to this method anywhere within your T-SQL. It doesn't have to operate in the context of an existing spatial data type column. So what it does is we're going to construct a well-known text format. And the well-known text format, and you could look this up, you could Bing it and get more information on it. For a point, it begins with the keyword point, left paren, a longitude, a space, and latitude. And if we just go out here, we're going to actually look at 3 different methods. This is the first method. And if we go out to msdn.com and we search on SQL Server spatial data type, or if you search the geography data type, you can get to this method reference. And so here's a list of static geography methods. And sure enough, here's STPointFromText. And you'll notice that a spatial data type method is always preceded by capital S, capital T. And PointFromText, if you click on that, takes us to the document entry for STPointFromText. And of course, we provide all the nifty samples that you can use. Okay, so back to our task at hand. We're going to insert from the stage table all the columns, and we're going to add at the end this incident point, and that will be constructed by calling STPointFromText and passing it in the long and the lat. So let's go ahead and do that. And we'll execute. There we go. We can see that we've inserted the 1,779 rows. Now let's go take a look at that table. We'll do a select star from SanFran 311 report table. And there we go. That same result set that we saw on the stage table, but if we scroll to the end, sure enough, you see this this binary looking incident point, and sure enough, that's the internal binary of our incident point we created using STPointFromText. But look at what else happened when I selected from a table that has a geography type. Look at this spatial results tab here. That spatial results tab says, oh, I can see that what you've selected, there's a column in there that's of type geography or geometry. So I'm going to show that to you. I'm going to render that for you more the way you would expect for a spatial data type. So let's take a look. So I'm going to click on spatial results, and I'll hover my mouse right there. There it is. Can you see that tiny little, that's not a mark on your screen. That's around 1,700 311 incidents in San Francisco. Just happens to be that our grid is enormous. It's probably covering the greater breadth of California and then some. So I'll just go ahead and zoom in on that. And if you know San Francisco at all, you'll notice that these 311 incidents start to take shape. There it is. There's our fly, our little blip. And I'll just try to keep it centered here. And sure enough, as I zoom in, look at that. That looks a lot like the city of San Francisco. And you can clearly see that there's quite a number more of those 311 incidents over here in the eastern flank of SanFran, and then fewer out here on the perimeter. Just an interesting note. So there you go. That's using the spatial results, and you can see that I've successfully loaded those float lat longs into a spatial data type, and now we're looking at them. But our job isn't done, because recall that report had not only the lat long for the 311 incident, we also had a notion of the line string that represents the streets in San Francisco. So we need also to get those line strings. And I did a little bit of data loading to retrieve those roadways, and I pulled it down from the National Highway Planning Network. And you know what? I found this data set simply by using some Bing search. And when you go out to these .gov sites and you search on this stuff, you'll often find publicly available shapes of counties, incident points for any public government item, as well as all the line strings for the national highway system. So I'm going to show you the website that I found this. This is where I found the shape files that have the line strings for all the national highways. And I just went out to this bts.gov site. This was the result of a Bing search. And you can see down here that I can get the 2011 and 12 data. And if I come down here, you can see there's some zip files in here. And I'm looking for these polylines right here. And here it is, the National Highway Planning Network, and there's a zip file. And when I pull that zip file down, what do I get? I get a bunch of data, but most importantly, here's this .shp file. That's a shape file. I need to take that shape file and load it into a SQL Server table. So to do that, I went ahead and loaded the National Highway Planning Network shape file. We'll get back to our SanFran. I just want to show you the this shape file. I happen to load it into a table called NHPN, and here it is. And there's a whole lot of indicators in here, like the miles for the road segment. We have, most importantly though, this geography type. So I have all of the national highway roads, and that's a huge table. What I want to do though is I want to extract the San Francisco roads. So the FIPS code for San Francisco County is 75, and then I'm using the state code of 6. So give me the road name, the miles from the NHPN table, and I'm giving them some more readable column names, the begin and the end mile posts, through lanes, and then the road line string, which is the geog type. That's the spatial type. So now let's go ahead and run this. I'm going to create a view called View SanFran Roads Geog. And I've already created it. Sorry about that. Let's run the select statement that's part of this view. There we go. And there's around 872 roadways in San Francisco. So now if I go to spatial results, we'll see what looks a heck of a lot like a road grid. Big surprise. And there's our road segments for San Francisco. So now we have our incident points for 311, and we have the road segments. Let's take this a bit further now. And I'm going to select the road name, the miles, the begin and end mile posts for Van Ness. But I'm going to use a couple more methods. Notice in this case it's not a static method. Here's one called STIntersects, and here's one called STBuffer. But they're hanging off of a column that's of type geography. So these methods, when executed, will apply to the preceding column that is a geography type. So what I'm doing is I'm saying, hey, convert the geography type to one of those well-known text formats, just so I can read it. This is just out of interest for us. But also take that line string and draw a buffer around it that's 100 meters. Now notice that I haven't asked for a specific road segment. I've just asked for all of South Van Ness Avenue. So I should see a few little connected like caterpillars that represent the different segments, and they should be a little wider because this STBuffer is actually returning a polygon because we're drawing a little buffer around a road. So let's go ahead and select. And now you can see the road well-known text format. Do you see the well-known text format for a line string? It begins with line string left paren, and then we have the associated longitude, latitude separated by commas that represent those road strings. So let's go to spatial results. And there we go. There's the returned polygons that come from the result set. This represents the call to STBuffer. So what you see here, that's the geospatial rendering of STBuffer, because STBuffer returns a geography type that's a polygon. Of course, it's not persisted because we're just simply calling the method and it's getting pumped out as a result set. We're not putting it anywhere. So that's what you see here is the road buffer. So what do we have now? We have our incident points. We have this table that has this view that has access to all the roads within San Francisco. And I've introduced you to the method STBuffer. And again, you can go back to the Books Online pages to look at all the different methods available to you. And just really quickly, what the heck, I'll go back and show you, or will I? Let's see here. There we go. So I showed you some of the static geography methods. So then there's just a bunch of methods that you can use on geography instances. So here we go. STBuffer, that's a method that I hung off of the line string that represents the roadway. Okay. So now I want to take a step further, and I'd like to create a view that gives me a milepost that has the string miles long, begin milepost, end milepost. And I just want to make this thing a bit more usable and readable. So we'll go ahead and this view's also been created already, but I'll show you what it looks like, what the results look like that are behind this view. And so now we can see the SanFran road name, and then the milepost markers, and then the road segment sequence. This will be used in part 2 of our session. So to conclude our session then, let's bring it all together. I'm now going to run a select statement, and this select statement is the same result set that we used to render this report. What did we ask for this report? We asked for a 100-meter buffer around Ocean Avenue for the road segment that starts at, that's 1.25 miles long, and it begins at 1.26 and ends at 2.509. Behind the scenes, that's road segment 3, or is it 1? We'll look at my T-SQL in just a minute. And then I've said, and for that road segment, give me all the 311 incidents that are within that 100-meter buffer around Ocean Avenue. So here we go, and this will wrap up our session, but this is the big finish for part 1. So, first of all, what are the tables that I need to select from? Well, I want my view that has the SanFran roads, right? So that's the view that I set up earlier. I need that. And I also need the report table. The report table has our 311 incidents. What I need to ask in my where clause are some good old-fashioned predicates, like road name equals Ocean Avenue, like road segment sequence is sequence 1, right? I need to do that, but I also need to do something in my where clause now that leverages the spatial data type, and this part's pretty cool. So I'm saying for the incident point, the 311 incident, that point, that's the geography type, right? One of the methods that I can use off a geography type is STIntersects. You can probably see where I'm going. So I'm saying where that point intersects, well, intersects what? Well, STIntersects, it expects a geography type for its argument here. Let's go look at STIntersects. Where is that? Here it is. So, .STIntersects, and then it expects another geography type. Okay? Well, remember, STBuffer returns a polygon. And so we're saying where that point intersects from the view that gives us the roads in San Francisco. Road line string is a geography type that happens to be all line strings. And then the method I'm hanging off road line string is draw a polygon that's 100 meters wide. So where does the incident point, where does it intersect that polygon, which happens to be that 100-meter wide polygon around Ocean Avenue? Where that equals 1. And the type, like graffiti, and the status of the incident is open. It's this right here that's the spatial intelligence stuff that you simply can't get with a where clause. If you did not have that spatial data type, and you're a data architect or a designer or a DBA, and someone came up to you and said, give me all the 311 incidents that are within 150 meters of this section of Market Street, because we're going to start a massive city cleanup project, and we're going to start in one of the very visible streets to the tourists. So I need all the incidents that represent abandoned vehicles and graffiti. Well, if you didn't have a spatial data type, you could say, okay, I better try to find all the roadways that kind of intersect that segment of Market Street. So first I better find the 311 incidents that are recorded as being on Market Street. Okay, cool, I got those. But what about those 311 incidents that are off Market Street, on one of the side streets? They're still within the 150-meter buffer, but they're on another street. It's pretty hard to say with traditional where clause and discrete data types, it's pretty hard to say, oh, and close to Market Street, pretty tough to do. So hopefully that shows the power that you can, well, the amazing power that you can add to a data set when you include geospatial awareness to your data. The ramifications, you know, and what you can begin to think of and dream of when you think in terms of polygons and line strings and points and mashing them up with your traditional data, it's pretty profound. So enough of that. Let's go ahead and just select. And there you go. I have the very incident points that I have on my beautiful report here. So that's part one. Thank you, and please enjoy working with the spatial data type.